Hello guys, welcome to my YouTube channel. So today we will be solving Leetcode weekly contest 369 problem 4, that is maximum points after collecting coins from all nodes. Okay, so pause the video, read the question, then I will explain. Cool. So what the question says is that we will be given an tree, okay, undirected tree. So that's basically just a tree, normal tree. Okay, rooted at node 0, and and what we need is we will be given just edges to construct this tree, and we will have one array coins which will be nothing but representing the coins stored at node ith. Okay, and we will have one integer k. Now now so what the question needs is to we have to collect these coins. Okay, but we can collect this coins in only two ways. Either we can collect the coins in such a way that if we collect from the ith node, we will get coins I minus k points. Okay, and if it is negative, then also we'll have to subtract from it total coins. Else we can take coins by 2 coins and rest all the nodes in the that subtree, their coins will be halved. So it's better to explain here. So what it is saying, that let's say this is a subtree, very basic subtree. So we are at this point and it has x coin. So either, and we have, let's say, total coin at sum. So for this we can do operation 1 and collect k minus, so sorry, not k, coins minus k of I. So so basically here it will be coins of I, sorry, coins of I, that is, we know that how minus x, sorry, k, and we know that this is x and this is k. So basically our sum will become sum plus is equal to x minus k. So sum will increase by x minus k. If it is negative, that means sum will decrease. If it's positive, then sum will increase. Okay, that's one way. Else what we can do is we can collect x by 2 coins. We can collect x by 2 coins, that is, sum will become sum plus x by 2 coins, and all the coins, let's say here it was something like 2n y or m, something like this, then this coin will become n, this coin will become y by 2, and this will become m by 2. Okay, and we will always take the floor value, not seal value, floor value. Okay, so we are clear till here, right? So we need to do to perform two operations. Either we can collect coins of I minus k, or else we can take x by 2 coins, considering that it will be x coins. Okay, now if let's say we have performed this operation over here, like operation 1, then we can perform any operation from here. Or if let's say we perform operation 2 here, okay, then it had become, initially there were 2n coins, but performing this operation the coins are reduced to n. So though initially it was 2n coins, but here it will be n, and instead of y, here it will be 2y. Now at these nodes as well, we will have similar kind of option, right? Either we can take this, like this updated coin, that is coins I or y by 2 minus k coins for this node, we are talking about this node. Okay, or we can take y by 2, we know that we can divide it by 2, and all the sub nodes, all the subtree, sorry, all the nodes in the subtree will get divided by 2. So either we can take this many coins, then in that scenario we don't need to do anything with the subtree. But if we are taking y by 2 coins, then we'll have to divide all the y by 2 by 2, sorry. Okay, so we'll have to divide the coins in the remaining nodes. Okay, better to visualize it with some example. Let's say here it has for 10 coins, it has 7 coins, it has 3 coins, it has 4 coins, and it has 5 coins, and k is, let's say, 100. So what we are deciding over here is that here you will be taking total number of coins divided by 2. Then in that scenario what will happen, that our coins will get updated to, here we already have, initially our sum was 0, the total coins, so here we will get 5 coins. Okay, here it is 7, right? But we have taken by the second operation, then that means the moment we have taken it using the second operation, that means it would have been updated to 7 by 2, that is 3. This 3 by 2, that will be equal to 1, This is 4 by 2, that will be equal to 2, and this 5 by 2 will equal to 2. Now our new tree will look something like this. Now again we'll come at here, we'll see how much coin like in which operation, by way 1 or by way 2 we want to keep take the coin. So here we can see that this is 3, and we decide, let's say for the timing, we decided to go with k minus the first approach. Then from here what we'll get, we'll get 3 minus 100, that is minus 97 coins. Okay, so our total coins will become my 5 plus minus 97, that is equals to minus 92. Okay, then in that scenario this will be done, this will be left as it is. But let's say instead of this, if we have chosen to take n by 2 coins, or whatever 3 by 2 coins from here, then in that scenario our total coins will become 5 plus 3 by 2. Now this will be again divided by 2, right? So this will be, sorry, this will be divided by 2 and it will become 1, this will become 1, and this was 1 by 2, that will become 0. So our new updated node coins will be this one. Now we can come to this and this node. Okay. So I hope the question would be clear with you. It's the most important point, to get the question clear, because the solution is here itself. If we got the question, now what we can see is at each node we know that it will always be rooted at 0, right? That is written in the question. So what we can do, or what we can see from here, is if we want maximum coin here, what we will have to take, all the coins from this subtree, sorry, all the coins from this subtree, all the coins from this subtree, and all the coins of this subtree, plus the coins over here. Okay, now so like going in the basic approach, what we can do, we can simply run a DFS, because we know that we using DFS we can traverse this entire tree, right? So what we can do, we can do both. Let's say if I am taking at, or it's better to write over here, that what I can do. So first of all, let's say we are running a loop, so we are passing node, and all the other parameters will also be there, but for the simplicity let's consider only node. So if let's say we are just passing node, then for this node I have two options. What are the two options? First of all, if I am at nodes, so I can take coins of node by 2. Let's say this is stored in some or someone, let's, okay. Or else, what is another approach? Let's say sum2 is equals to coins of node, coins of node minus k. Okay, these are two possibilities. Now, but if I am taking this one, if I am taking this one, that means in this scenario, I'll have to traverse entire subtree and divide their values by 2. Divide their values by 2. Okay, but can we do something better? Because if we will do this for n nodes, then it will return, or overall it will become O of n square, which will give TLE. So we cannot go for each node, iterate for each subtree and divide it by 2. So how can we do it? How can we do it? So what we can do is, we can have one additional parameter over here. Let's say there is some additional parameter, let's say x. Okay, and what will this x represent? So x will represent how many times we have to devise this particular value. So if say this was the node, right, or this was the root, and after some places here it is some coins c. Now in between we have performed 2 times operation second. And what was our operation second? That will be choosing the coins by 2, whatever the coins at that particular node, by 2, and divide everything in the sub node or subtree by 2 for that particular operation. So let's say if we choose n by 2 coins over here, then we'll have to divide everything by 1. So what we can say is that we can have one variable 0, that before that we have not divided any time. So we can simply have a variable 0, but once we divide it, that means we will be taking how much coins from here, n by 2, or we can say we have to divide it by 2 one time. Let's say and also all the nodes in the subtree will need to be divided one time. So the actual coin value will be decreased by 2, factor of 2 for every coins. Now let's say here as well, we are dividing it or taking the second operation. So let's say initially here it was coin x, uh, it needed to divide it by 1 because we have already performed operation 2 in the top node, so it needed to be divided by 1, so already it had become 2. And now if I am taking the second operation, then that means I'll have to divide it by 2, or better what we can say is that initially I have to divide it by 1 times by 2, now I have to divide it by 2 times. So similarly, what I can write, x divided by 2 ka power 2. Okay, and for the same subtree, or for the subtree, what we can do is we can just increment this value to 2. Now one thing to realize that we'll be traversing this tree using DFS, right? We'll be traversing this tree using DFS. So whenever we'll be at the root position or at any position, so let's say there was this count of divide was, let's say, f, then if we are dividing that, if we realize that, right, like if we would have performed operation 1, then we don't need to divide everything in the subarray. But if we are performing operation 2, that means we have to divide everything in the subarray. And then this f, what it was representing, it was representing the number of times we need to divide any node coins, right? So we can simply increase it by 1 and we'll pass f plus 1 in the child. So what I am saying is, listen carefully. So I am saying that it was part of some bigger tree, let's say. And till here we know that we have to divide f times in the sense we have to divide whatever the value here. Let's say c, we will divide by 2. How many times? F times. One time, then again divided by 2, then again. Or we can simply write c divided by 2 to the power f. Okay. And if we are taking the coins by the second operation, that is by dividing the coins over here, then this right, all these sub nodes in the subtree needed to be divided by one more time. So though it was f here, these coins should be divided by f plus 1 times. F, these coins should be divided by 2 f plus 1 times. I hope that would be clear. Sorry guys. Now how can we do this? Either we can raise to the power 2 to the power f, we can do that, or simply we can use right shift operator. So I'll just explain a bit. What right shift operator does is, let's say if we have x, right shift y and store it in something, then c is nothing but x divided by 2 to the power y. So this is basic bitwise operator. So you can read it about more, or say ask in the comment section. I'll make a separate video on that. Okay, so till here everything is clear. Now let's do one thing. So we were at the root node. We have two possibilities: either we take it by operation 1 or take it by operation 2. So what we will do, we don't know what will be the maximum value, so we'll always maintain two variables, let's say sum1 or curve and sum2. So if we are taking, or it's better to go through the code, that will be much easier to understand. So let's say, oh sorry, there will be a bit of difficulty, just ignore this dp part right now. So let's say this was f, right? This was f. We are doing nothing but we are just traversing, right? So we'll be traversing. Initially, let's say we are here. Now initially we know that we don't need to divide anytime, so we can simply pass node comma 0 or 0 comma 0. 0 is basically node number, then node number, and this is the number of times we have to divide. Okay, so initially it will be 0 and 0. Now at this node we have two possibilities, right? What are the two possibilities? I can take, let's say here its value is c, okay, or c0, better to write c0. Similarly c1, c2, c3, c4, c5 and c6. Now if I am at c0, and and if I have two possibilities. What, first of all, if I take c0 minus k coins, that's one possibilities. Okay, in that scenario, do I need to do anything? No, I don't need to do anything. Don't need to do anything means, like, whatever the f times or the number of times we have already divided this entire subtree, because let's say if it was coming from somewhere, or if it started here, that the remaining subnodes, also needed to divide it 0 times by 2. Okay, so in that scenario, what we can do, we can simply pass for all the child, that is child and the same f we have. Okay, but let's say if I would have taken it something like this, c plus 0 by 2 coins from here, then in that scenario what we'll have to do is, we'll have to pass dfs of child. And now see, as we have done operation 2 over here, that means we have to divide everything in its sub, in everything in subtree one more time, right? So we can, in that scenario, we can simply add f plus 1. Okay, so in that way, what will happen, we can always and these dfs call will return nothing but the maximum value that we can get from that particular subtree, or whatever the child we have. Okay, so now there is one more thing, or one more important observation, because see, what we can do, at each node we can divide, right? So the value of this child will also go from like 1 to, or 0 to n minus 1. And if we are dividing at every node, then also this f will go from 0 to n minus 1. So overall it will become O of n square. But we know that O of n square solution won't be accepted, because n is here 10 to the power 5. So, but there is a small observation, that let's say f, what is f? F represents number of times the particular node is divided by 2, is divided by 2. Okay, is divided by 2. So let's say if there was value some 10, and I said it will be divided, and for it f is equals to 2, that means f will be 10 will be divided by 2 times. So first of all, it was 10, then it becomes 10 by 2, and it becomes 5. Then 5 will again be divided by 2, and it will become 5 by 2, and that is will be equal to 2, right? Similarly, if we'll realize, or if we'll see the question, we are given that the maximum number of coins is 10 to the power 4. So you will realize that 10 to the power 4 is less than 2 to the power 14. Or can't we, or we can simply say that if this coins is divided by 2 to the power 14 times, we know that 2 to the power 14, or let's say for simplicity 2 to the power 15. So 2 to the power 15, let's say 2 to the power 15 is greater than this 10 to the power 4. That means what will happen, if we'll keep on dividing c, or we'll divide c by 2 to the power 14 times, the remainder will become 0, because that's what's happened, right? Like if there's a smaller number x, and if y is greater, then this remainder quotient will be 0. So we can realize that if at some point f is equal to or greater than equal to 14, or let's say 15, that means we don't need to worry and increase this, right? Even if, why I'm saying that, that let's say if this is a subtree, and in subtree I have 100, and I have, let's say, 200, and at one time here f was 5, then f for if f was 5, that means we'll have to divide this by 5 times. Okay, so if we'll see, that will be f divided by 2 to the power 5 times, that is f divided by 2 to the power 5, that will be nothing but 100 divided by 32, and it will result 3. Similarly, it will be 200 divided by 32, sorry, not 35, 32. Yeah, so it will become 6. But let's say if I am saying that I have made it 10, okay, I have made it 10. So in one iteration, I have got it 10. That means 100 needs to be divided by 2 to the power 10, and 2 to the power 10 is 1024. So 100 divided by 1024, that means it will be 0. Similarly, 200 divided by 1024, this will also be equal to 0. So even if we are at this node and f was 10, let's say f becomes now 11, or f becomes 12, or f becomes 13, does it make any sense? I mean, anyways, if for f equals to 10 we are getting everything as 0, because this node value will become 0, this node value will become 0, then for f equals to 12 also, 11 also it will become 0, f equals to 12 also it becomes 0, f equals to 13 also it become 0. Okay, why we are discussing that? Because we know that At max the coin value can be equal to 10 to the power 4, which is almost less than, or which is less than 2 to the power 15. That means once f has crossed 15, f is greater than 15, we don't need to move forward. We can simply restrict f at 15. Okay. And there will be one more benefit, because it will won't overflow, because like 2 to the power 100 we can't calculate it and store it, right? So it's better when f will be equal to 15, we can simply restrict it. Okay, we don't need to increase f further. I hope this point will be clear. So our solution will become very simple now. What we are doing, first of all, we are just making we are taking out n from the coin size, we are making an adjacency list and pushing all the edges. Now we have started iterating from zeroth node, because the root is at 0. We are passing the parent so that we don't visit the visited nodes, and this is the rf what we discussed in our solution. Now at each position, just ignore this part for the bit. So like it at each position, what we can do, we can either take coins of node divided by 2. Okay, so divided by 2 in the sense, see, we already know that this coin was divided by 2 f times, or needed to be divided by f times by 2 already, because of the ancestors. So like, so what we have is that these coins needed to be divided by 2 f times. Okay, already. So if we are taking n by 2 coins here, that means we will have to divide it by f plus 1 times. That then we have one variable here. We can see that this is x, f plus 1 times. Else what we can do is, whatever the coins we have right now, we can just take coins minus k. And we know that this coins of node needed to be divided by f times, because we have performed the second operation before this already, f times. So our effective coins and minus k. So these are the two possibilities, right? And if we are taking the first possibility, that we are dividing it, if we are dividing it here, then we have to pass f plus 1, that is x, or better write, instead of x, let's write it f plus 1 everywhere, so that will be better. Okay, and here also we can write f plus 1, because why? Because we are dividing here, right? Because in the current we are storing the result which we will get by dividing. So but if we are not dividing it, we are just simply subtracting k from it, then in that scenario we'll have to pass the same f, right? So we have just passed it, and whatever the maximum value of this curve is, we can simply return. Okay, and now we have, this will give tle. So what we did was, we just adding tp on which states node, because we know that this node and this f will change, right? This node and this f will change. This parent will always be same for any particular node, so we can ignore that. So our state will depend on simply node and f. Okay, so we put a dp. If it is not there, we will calculate it. Else, if it is there, we can simply return it. And finally, we are storing the result. Let's try and submit the solution. Okay, so it's getting a bit error. So it's better to write F. Okay, so we have already met 16. Just give me a second. It's, if we'll write it over here, 17. Because we are passing 16 here, right? So it got AC. The reason was, here we are passing a plus 1, right? So even if it was 15, we would have passed 16 over here. Again, maybe it will, again in next iteration it will become 15, but we have passed 16 and we was checking over here. That's why it threw the error. But now it's okay, because we have put 17 over here. So it will be like n cross 17 dp or n cross 15 dp if you want to reduce it further. But I hope you got the solution right. Do let me know in the comment section if you guys have any doubt on this question. Okay, thank you.